What's going on, guys? Obviously not in class today. Got this video note thing putting together for you guys today. You guys, as you notice, hey, check out the production value if you've seen my videos in the past. Hey, picture in picture. And then look, I put a little table with the things. Like, yeah, I'm so special. All right, so today what we're going to do is I wanted to, because I told y'all to try out some examples that I wasn't able to get to today in class. I think fourth period we kind of skipped ahead of this one, whereas in third period we were able to jump in that. So let's show you guys this. There's that one. Now's a good time to pause if you want to grab it, because I don't want to spend too much time on this. Okay, now for all the rest of them, I think for both classes, we had these. Okay, so here, actually, let's zoom in Podvin one at a time. Okay, this is what the negative cosine would look like right here. Go ahead and pause. Okay, if you want to copy that down. There's what the negative 2 sign would look like right there. Everything's just kind of flipped. We'll talk some more on Thursday when I come back about that. If we got questions, go ahead and pause if you want to put that down. And then lastly, we have this guy right here. Okay, so we had that sign of -2. Everything just shifted down to. Again, we can talk about these a little bit later as that comes up. So here's the idea. I gave you guys a couple challenges. Let's go ahead and I'll just do those challenge problems. Okay, what the idea behind those challenge problems was down here at the bottom that I challenged you guys to do was that we're mixing together both transformations. So we had 2 of them going on. Okay, we're gonna have an amplitude change right here. This is our amplitude. Okay, we're gonna change that amplitude. We're also going to have a shift up. Okay, so we're gonna shift up 1 based on this. This is gonna change our midline to 1. Okay, so let's go through and let's check that out. Dude, I'm just admiring my picture right now. Sorry, this is legit. I'm doing pretty good here. Give me comments later on the audio, okay, when I come back on Thursday. I got a new mic, so yeah, it should be much better. Okay, so let's go ahead and do this. We're gonna scale it like we always do. Okay, we always got to scale it the same way. Every 3 boxes on the x's is gonna be a pi over 2. So 6 boxes is pi. 3 pi over 2, and then 2 pi. Okay, so that's how we're going to scale the x-axis. The y-axis we're going to scale every other one is 1 unit. So there's 1, 2, actually let's take it up 1 more, 3. We'll just take this guy down 1. Since we're going to be shifting up, things should be up there. Okay, first thing that I do after scaling, okay, first thing we do is scale. After that, I want to focus on where's my midline. Okay, it's always good to start with the midline. Where is that going to be? Where's that new 0 line we're going to have? So since we're shifting up 1, we're going from the x-axis to y equals 1 here. So that's my new midline. That's my new 0 line. My amplitude is going to come off of that midline, and then from there, we're going to go from there. Okay, so that's kind of the idea. Sorry, I'm trying not to just stare at the paper. Okay, so now we got to think about cosine. Cosine usually starts at 1. It ends at 1. Okay, we're going to reiterate that later. But right now, it starts at 1. It ends at 1. In between, it's at -1. But see here, here's the issue here. Our amplitude is going to get changed by -2. So every one of those things ends up getting multiplied by -2. So instead of starting 1 above my midline, like cosine normally does, what I'm going to do instead, since it's going up 1 to start, we're going to go down. We're going to start -2, so that's going to be 1, 2 down here. So really we're going to start down. Normally cosine starts up, but the negative forces us to go down. And instead of being 1 unit away, we're going to be 2, because again, that's what our amplitude says. We got to be 2 away from our midline. So we start at -1, and then when we're done with the full cycle over here with 2 pi, okay, we're going to end at -1 here, okay? Also 2 away from our midline, okay? We start and end in the same place with both of these. Halfway in between with cosine is usually 1 below my midline. But again, we're flipping things and we're changing our amplitude. So this is going to be, instead of an amplitude of 1, it's going to be an amplitude of -2. So we're going to go the opposite way. So we're going to go the opposite way by 1, 2. That's going to take us all the way up here. Okay? At pi over 2 and 3 pi over 2 for cosine, we are on the midline. We are on that 0 line. So those guys are right on there. So we're kind of like flipped over. Okay, so what happened to cosine isn't that, wow, that was terrible. I just drew that so bad. Okay, instead of being one big valley like our normal cosine function, this one's flipped. Okay, it's one now big hill. All right, so that's what happens to it when it flips, and how we can put them together. All right, our range. Good thing I caught that. We go from -1 is our lowest, and then our highest is 3. So we'll go like that, lowest to highest. All right, so there's that one. Sine. Let's look at this next one. Let's look at this next one over here. Okay, we'll look at you. Hi. So 2 things. Down 2 from this guy. Okay. And then this is going to be our amplitude. Our amplitude is going to be 3 halves. We'll see what happens when we have to deal with that. So first things first, we got to scale it. First things first, we're going to scale. The scale always tends to look the same. All right. Scale the y-axis. Not too far up. We're going down. So we need to go down. -1, -2, -3. We'll take it all the way down to -3. Actually, you know what? Let's make -4. Forget it. Let's do that. Okay, so here's the idea. What we're going to do is this. Okay, our midline now. So the first thing we want to do, check out where that midline is. We can draw that in, that dotted line. It's going to be at y equals -2. So we're down here. There's our new midline, our new 0 line. Okay, everything's going to go off of that. Sine always starts on the midline and ends on the midline. So it gets a little confusing because it actually hits the midline 3 times. It actually hits it 3 times. Sorry, I realized I wasn't on camera. Okay, 3 times. So what happens here is this. We're going to start on the midline. We're going to end on the midline. So again, 1 full cycle takes us 2 pi. And then halfway between, we also cross the midline again. Okay. And then what's unique to cosine or sine compared to cosine is that sine, it starts by going up. Okay, normally it goes up by 1, but our amplitude is 3 halves now. So instead of it being up by 1, we're going to go up 3 halves. Luckily, we used our boxes as being 1/2 each. So we're just going to go up 3 boxes because that's 3 halves. So from our midline at pi/2, we're going to go up 1, 2, 3. Okay, that's up 1, 2, 3 boxes. So that'd be 3 halves. Okay. Once it goes up and then down, it's going to 3 pi/2 goes below the midline by our amplitude. Amplitude's 3 halves. 1, 2, 3. Boom. Connect the dots, making it round. Oh my gosh, that looks so much better. Okay. So there we go. That's what that one looked like. All right. Again, we're going to have a big old recap on Thursday. Don't worry. Okay. We'll have a big old recap. We'll get everybody on the same page. Please, if you've made it this far, make sure your classmates are actually on task. Like, goodness gracious, nothing would make me more PO'd than if I come back and it's like nobody's got this down in their notebooks. I mean, in their packets. Like, come on. Like, okay, just like nudge your neighbor. Make sure they're doing what they're supposed to be doing. All right. Making you guys police yourselves. All right. So those are our challenge problems. We're putting the 2 transformations together. All right, so we'll start working on that. Next, let's move on. Let's try something else. Let's hammer home. Here, I just flipped the page, just so y'all know. Okay, we're on this page now. Okay, here's what I'm trying to do here. Okay, here's what I'm gonna do. I'm gonna give you guys a nice overview of how just the basic sine, cosine, and sine. How I can do those ones just like straight up, just the basics. Okay, with those basics, then those transformations happen from there. Okay, and that's what I'll keep talking about. When I say things like, cosine starts at 1, ends at 1. Sine starts on the midline, ends on the midline. Those kind of things. Those are those little things, those hints about like how you're supposed to graph this, and your methods about going about it. So let's actually hone in on cosine first, and then I can talk more detail about those things that I say, so that maybe it's a little more clear. Let's try that autofocus again. That looks out of focus. Much better. All right. So as always, scale first. Oh, whoa, not 2 pi. That's just a regular pi. Okay, 3 pi over 2 pi. Okay, always scale first. Get that scale in there. And it's always scaled the same way, so there's really no surprises. I mean, there's going to be some examples where we're going to change the scale, but we'll get there. Okay, we'll get there. You know what? Just because I probably forgot the last problem, I honestly don't remember. There's my range for this one. Just I'm thinking about it right now. Cosine starts at 1, ends at 1. 1 full cycle is 2 pi, so it starts at 1, ends at 1. Halfway between, we're at -1. That is cosine, okay? Starts at 1, ends at 1, halfway between at pi, we're at -1, okay? At pi over 2 and 3 pi over 2, or halfway between, like my quarters, I guess you could call those are going to be on the midline, which if we haven't shifted or anything, those are right on there. And then that describes exactly how we would just do a basic cosine. Again, it starts at 1, ends at 1, halfway is at -1, okay? And then for my quarters, my 1/4 of the way and my 3/4 of the way through the cycle, we're hitting the midlines again. Okay, so you're gonna hear me say that a lot. Okay, you're gonna hear me say that a lot because it's how it works. It's how you can get all those 5 points that we need. Okay, so we can graph those accurately. All right, so that's cosine. Here's sine. Here's sine. Very same range. Okay, see, I'm getting ahead of myself here with the range. Okay, always scale first, no matter what. Doesn't matter which one you're working on. Got to work on that scale first, or else it just doesn't work. Okay, you just get out of order. There's an order to things. Okay, there's an order of making this thing work and making it work well. Okay, I skipped too many there. -2. Okay. All right. So once we're scaled, all right, sine starts at 0, ends at 0. So starts on the midline, ends on the midline. Okay, halfway between, it's still on the midline. So sine, see the difference here? The cosine over there was starting on 1, ending at 1, and then when we got halfway through, it was a different point. Sine starts on the midline, ends on the midline, halfway is on the midline. Okay, sine always starts by going up. Okay, so my quarter for pi over 2, we're going to be going up. We got to make the hill first. Okay, once we made the hill halfway between the other two, we're making the little valley here. So we make the hill first and then the valley, and then there we go. Now we've got a little sine function. Those are just, the quick and dirty way of just the parent function. Okay, sometimes it might be helpful to write that in pencil, and then once you know your transformations from your equation, then you kind of like spread things out and like maybe change where your points are. I don't know. That's not how I do it, but all power to you if you can make that happen. All right, so that's kind of the idea with those ones. What I would like to introduce today, and just introduce, I mean like literally just kind of show you, okay, is changing the period. Okay, we're going to call that's going to be the B, okay, for stretching and compressing horizontally, okay, or changing the period, okay. We're also going to introduce left and right horizontal transformations, so meaning like we're going to shift left and right, okay. In class on Thursday, we'll start putting all these things together. Let's start putting them together. Right now, I'm just going to introduce them separately, and then we'll kind of go from there. So, let's frame what I need next. Here's the most important part. Right here. Okay? If we look, okay, functions that have some kind of b, some kind of thing on the inside of the parentheses that we're multiplying by, that's going to be our b. Okay? What that does is that changes our period. It changes our period by this little formula right here. Normal period is 2 pi. All right? That's our parent functions. But when we do this transformation, we get our new period or our new full cycle from this formula right here. That period is going to be 2 pi divided by whatever b is. All right? So, here's what happens. Here's the meat and potatoes here. So, we've got cosine of 2x. 2 being in with the x means that this is a b value, okay? It's going to change the period, so they gave us a little space to write the period. All right? My period, again, it's going to be 2 pi divided by b. In this case, b is 2. So, a little bit of simplifying here. This is some ground-breaking stuff here. 2 cancels with the 2, and we get pi. So now, what that means, okay, remember the period means how long it takes to go through a full cycle. Now, our parent functions, those take from 0 to 2 pi, so they take 2 pi to be their period. This guy just had his period cut in half. Okay, so that whole cycle has to now happen. Instead of 2 pi, it has to get all scrunched together. Now it has to happen in half the distance. So now it's happening in pi distance. So right here, we got a scale. We'll scale like normal. Okay, it's just going to scrunch it like crazy. but we're going to scale it like normal. Put in a 1. We'll just put a 1 and a negative 1. That's all we need there. Okay. Again, we're going to use the same convention. It's cosine. So we're going to start at 1. We're going to start at 1. And then we're going to end at 1. But now our period is pi. So instead of ending at 2 pi, we are going to now end at pi. So we're going to start and end in a pi distance. So my whole cycle's got to be contained in that half the distance that it normally is. Okay, we're going to use the same convention. We start and end at 1. Okay, start and end at 1. Halfway between our start and our end, we're going to be at -1. So at pi over 2 is now our halfway point. Okay, notice I'm starting to get away from calling them what they are. I'm trying to say like, hey, halfway between. Okay, so then halfway between our halves or in our quarters. Okay, so that would be like something like right here, and then the other one would be right here. Halfway between these guys, see, it's half of 3 boxes, so it's 1.5 boxes. Okay, we would have where we're going to cross our midline. So now it's a teeny tiny little waveform. Bloop. Instead of taking up all this, it's scrunched together now that the period's pi. And that's what happens. Okay, so now everything has to happen, that whole cycle has to happen within pi distance. And that's all that happened there. Our range, nothing happened to our range. It's the same as our parent function, -1 to 1. All right, that's the idea. When you're done watching this video, you're going to try, see if you can do it with sine. Okay, so here we're going to check this when I come back on Thursday. What a novel concept. Okay. Goodness gracious, look at that. Look at that stuff. Yeah, we're going to talk about what happens here. This creates some scale changes. It creates all kinds of problems. We'll come back. We'll come back to when our periods are this. So don't worry about these two. Okay, it changes the scale. It's like I said, sometimes we'll change the scale. Okay, but it happens. All right, we'll get there. Okay, we're going to get there. But here, let's start talking about horizontal shifts, meaning left and right. Okay, these ones, again, just like with the period changes, it's happening inside parentheses. It's inside like the function operator here. So what that does is that kind of changes things up for us. If we remember from function transformations, transformations for the x are opposite sign. So when this says minus c, that really means that we're going c to the right. Okay, we're going c to the right. So what that's going to do is that's going to affect our starting point. That's going to affect our ending point. So it's going to shift everything left or right, just like how we've shifted things up and down. Okay, so let's see how that works. So right here, we got cosine. Okay, we got cosine. It's plus pi over 2, and that's inside the parentheses. So what we need to do is remember, it's opposite sign for these things. Okay, it's opposite sign. See, it's like negative, right? These are negative. So it's opposite sign. This means we're actually going to go left by pi over 2. We're going left pi over 2. All right? So what does that mean? Well, that doesn't do anything to our period. Okay, there's nothing being multiplied here. So period's just going to be normal, 2 pi. We still are going to have 2 pi to get through the full cycle. But our starting point changes. Okay, our starting point changes. Here's what happens. Let's scale it like normal. Let's scale it like normal. Although we won't need the 2 pi. And you'll see why in a second. But we might as well put it in there. Good practice. 1 and -1. Good enough. Okay. So normally cosine starts at 0. Okay. Actually, that's where sine starts too. Okay. Normally that's where they start. They start at 0. Cosine starts at 1. The only problem is this. We need to shift everything to the left by pi over 2. Okay. That just so happens to be 3 boxes. Okay, so we need to change up our scaling a little bit. We can change up our scaling a little bit. We can go 1, 2, 3 to the left. 1, 2, 3 to the left. Okay, that gives us negative pi over 2, and that gives us negative pi. Okay, I took it a little further than we actually needed, but just trying to make a point here. Everything, instead of starting at 0, right? Starting at the angle 0, x is 0. And then starting at 1 and then ending at 1. We're still going to start at 1, but our new starting point has shifted to the left by or to the left by pi over 2. So that's 3 boxes. So now our new starting point is here at negative pi over 2. Okay. Now you'd be tempted to say, oh, hey, we're going to end at 2 pi. My period is 2 pi. But That's where we normally would end. But we're shifted to the left by pi over 2. So we're going to be right here as I spit over everything. Okay, there we go. Okay. So there we go. Everything's shifted to the left. We still start and end at 1. Okay, still start and end at 1. Halfway between my start and my end, so that now that halfway point is shifted to the left by pi over 2, is over here. That's where we'll be at -1. Okay, 1 away from our midline down below. And then halfway between my halves, or in my quarters, I've got crossing the midline, crossing the midline, just like that. It's that regular old cosine function. All that's happening is everything's just shifted to the left by pi over 2. Okay? No change to our range. That's looking pretty good. Okay? So the other one that I would like for you to try so that we can check tomorrow or check on Thursday is this guy right here, right next to it. Okay? Now we're, whoa, frame it, Podman. There we go. Okay? So you got 2 that I want you to try from the examples. Okay? From these new notes. Okay, this is your first time instruction for this stuff. So there you go. There's your practice that we'll check on when I come back. Okay, we'll have another horizontal shift, this time with sine. Okay, now, here's what you guys can do now, or should be able to do now. Should be able to do. Remember that ultimate goal at the end? The ultimate goal at the back? Ultimate goal at the back? This guy? We now have the tool set. We have the technology. Okay, we have the technology. You have the tool set. You should be able to do this. You should be able to do this. And I'm going to check to see if you did it or not. Okay, I'm going to see what you did. This is your homework now. Okay, homework. Do 9-19. What day is today? Today's Tuesday. Thursday is when I'm coming back. 18, 19. Oh, yeah. 19. Yeah, there you go. 9-19. Okay? First 4 problems. That's what it is. All right? Be nice to my sub. I'm sure he or she is doing an amazing job. And they deserve to be treated respectfully. As you all do. As we all do. As everybody does. Okay? Have an excellent Wednesday. Hopefully it's not raining too hard that day. Okay. I don't know. I got nothing. I don't know how to end these things. Like and subscribe. I don't know how this works.